Okay, so we're going to be doing x to the 1/5. So first thing you want to do, you want to get a basis to try to find a pattern. You want to find the derivative. So f prime of x is going to equal 1/5 x to the negative 4/5, right? And then f double prime of x is going to come out to negative 4/5 times 1/5 times x to the negative 9/5. So we're just going to keep running this out. Let's do it to the fourth term. So it's going to be the negative, well, negative times a negative is going to be a positive, so 9/5 times 4/5 times 1/5 times x raised to the, what is it, 14? 13. No, it's the 14. What's
Going
9
up
minus
by
5?
4.
What's 9 minus 5? Or negative 9 minus 5, rather, it's 14. So f to the fourth derivative is going to come out to negative 14 over 5 times
Oh yeah, you're right.
9 over 5 times 4 over 5 times 1 over 5 times x to the negative
19.
19 over 5. Okay, so I'm just going to set it up over here, this times x to whatever. So first thing I want to do is, we notice that we alternate signs, so positive, negative, positive, negative. So we're going to have a negative 1 raised to the n plus 1 power. So that way, when n is 1, we'll have negative 1 raised to the second is positive, n is 2, so that's negative 1 raised to the third, which is negative. So that works out for odds and evens. And then let's go ahead and grab the bottom of this. Notice every time, so like at our first derivative, we have 1 5. Second derivative, we have 2 5s multiplying 3 5s. So we can just say it's 5 to the nth power. And it just works easily that way. And then we're going to skip this other part for now, and let's go to the exponent. So we notice that we start at, for our first term, we start at negative 4, then negative 9, then negative 14, then negative 19. So every time it decreases, the numerator decreases by 5. So we can just leave the denominator as 5 because every time it's just 5. So then we're going to have a 1 minus 5n. What that's going to do, that's going to multiply in there. So it's 1 minus 5, which is negative 4, or 1 minus 10, which is negative 9, or 1 minus 15, which is negative 14. Just pans out easily and it'll keep the negative sign the whole way. And so now the fun part we're going to do, we're going to find what makes 1 times 4 times 9 times 14. So for that, we're going to go with a product series. So we're going to find the product from I equals 0 to n minus 1. Because notice, for every nth term, we get negative 19, or say at our third one, we have 14, but then at our fourth term down here, we have 14. We don't have it up here. So we only want to run to the previous term. We're going to basically copy this pattern, but just multiply it times itself. Because notice 1, 4, 9, 14, 1, 4, 9, 14. Okay. So then we're going to take the absolute value, because we already have our negatives and positives being controlled right here, so we don't want to mess that up. So the absolute value of 1 minus 5i. So let's test this. So let's say we're doing it for the third derivative. So we're going to say our first term is going to be 1 minus 5 times 0. That's going to give us 1 times 1 minus 5 times 2 times, oh no, 1, sorry. 5 times 1 times 1 minus 5 times 2. Because we're only running it out to the n minus 1, and since we're doing our third derivative, it's going to be 3 minus 1, which is 2. So the highest number we're going to get in here is 2. So then this comes out to 1, this comes out to 4, because remember we're taking the absolute value, it's not negative 4. So just 4, and 1 minus 10, which is negative 9, but the absolute value is so 9. So we find that we have our 1 times 4 times 9 is what we have here. So we just take this and plug it in.